question number 5 for today's section. A mass of object 2.5 kg is moving along a straight road in direction pointing 18 degrees north of east. Force whose magnitude is 49 Newton pointing 55 degrees to the west of south acts on the object. What is the magnitude of the parallel and vertical components of this force? Okay, well, let's first draw this scenario. Okay, let's mark down our 4 directions. So north, south, east, and west. So the object is initially moving on a straight line pointing 18 degrees north of east. So the way you think of that is you would be traveling east, but then you go north. So you go 18 degrees north. So this angle is 18 degrees. A force whose magnitude is 47 newtons pointing 55 degrees to the west of south. So again, you are traveling west, but you pull yourself 55 degrees, or you're traveling south, you pull yourself 55 degrees west. So that would look something along the lines of, I don't want to draw it exactly on the same angle, so let's say something like this. This is the force direction, it's 55 degrees. What is the magnitude of the parallel and vertical components of this force? Okay, so the important thing to note here is when you think of a billiards or a pool ball, and if you hit a ball which is already moving, let's say if this ball was moving here and if you hit it in another direction, it won't travel in the direction you hit it. It will travel in some other direction. Essentially, the reason I'm saying that is we won't use this 55 degrees in order to compute the components. This is actually at an angle of 55 plus 90 plus 18 degrees with respect to the object. That's the force which is being applied, and we would have to use that in order to calculate the forces on the object. So our theta is actually equal to 55 plus 90 plus 18 degrees, which is equal to 163 degrees. Okay, so it's 163 degrees from this point to there. Alright, and parallel and vertical components. Okay, so if you think of this as this, okay, so this would have 2 components. F would have 2 components, which would be F sine 163, which would be equal to 47 times sine of 163, which is 13.7 newtons. And the other component would be F equals to F cos of 163, which is equals to 47 times cosine of 163, which is equals to negative 44.9. Okay, and then okay, so when we resolve this, this would be acting like this. This would be one component like this and one component like this. So the vertical component would be, okay, that makes sense. So this component here is your cos theta, and this component here is your sin theta. So this is the vertical component, and this is the horizontal component. Okay. So again, that's the diagram of this question. You can append this to here to better visualize what it would look like, and then use that to get the angle. You get the same angle, and then use that to resolve the forces like we've done here. So the answers are correct in this case.